The report Highest Paying Jobs for 2009-2010 bachelor's degree graduates states that the mean yearly salary offer for students graduating with a degree in accounting in 2010 is $48,722. Suppose that a random sample of 50 accounting graduates at a large university who received job offers resulted in a mean offer of $49,850 and a standard deviation of $3,300. Do the sample data provide strong support for the claim that the mean salary offer for accounting graduates of this university is higher than the 2010 average of $48,722? Test the relevant hypotheses using alpha equal to 0.05. So first of all, let's look at a couple things here to try to identify what type of test we're doing. I see a couple keywords here of a mean yearly salary and another mean salary offer. It does seem like we're doing a test for a mean mu. I wanted to point out one other spot where we have a mean here, and that is a mean offer of $49,850 along with a standard deviation of $3,300. Now those numbers were based off of this sample of 50. This standard deviation is a sample standard deviation, not the population standard deviation, sigma. Sigma is unknown, so in this case we're going to go ahead and do a one sample t-test for mu. Because sigma is unknown, we're going to do the t-test. Let's start by describing the population characteristic. This claim here is that the mean salary offer for accounting graduates of this university is higher than the 2010 average of $48,722. So our population is accounting graduates of this university, and the characteristic that we're interested in is their mean salary offer. So mu equals the mean salary offer for accounting graduates of this university. Next, we need to state our null and alternative hypotheses. So we need a null hypothesis and we need the alternative hypothesis. Let's go ahead and state the alternative hypothesis first based on this claim. The claim is that the mean salary offer for accounting graduates at this university, that's mu, is higher or greater than the 2010 average of $48,722. So that's the claim that we need to see if we have enough evidence to support. The null hypothesis then is that mu is equal to 48,722. This is like the status quo. This is the easiest thing to believe. So our assumption is that the accounting graduates at this university have the same mean salary offer as all other accounting graduates. What we're testing is whether or not our sample data supports the claim that accounting graduates at this university actually receive higher offers on average. Once we have our null and alternative hypotheses stated there, we need to choose the significance level alpha. In this case, alpha was given to be 0.05. So we just need to state given alpha equal to 0.05. Now this is the threshold that we're going to use later on to compare our p-value to. Next, we need to check the conditions or assumptions required for this particular t-test. For all these tests, we need a random sample. We need to collect our data in a sound way. In this particular one, it did say that we had a random sample, so we do need to just reiterate that the sample was given to be a random sample from the population. Now, since this t-test is based on the sampling distribution of x bar, the sample mean, in order for the test to be valid, either the population must be at least approximately normal or the sample size must be large. So that's the next thing that we need to check. We do indeed have a large sample size. Nothing about the population distribution is given, but we have a large sample size, so we would just say that since our sample size n, which was equal to 50, is greater than or equal to 30, we do indeed have a large sample. Now, for a t-test, these are the only two conditions that we need to check, so we can go ahead and proceed with our t-test. So the next thing we want to do is calculate our test statistic. We're doing a t-test, so we have a t-test statistic here. And the test statistic is equal to the statistic, x bar, minus the hypothesized value, mu naught, divided by the standard deviation of your test statistic, x bar here. Well, that's normally sigma divided by square root of n. We don't know the population standard deviation though, so we're going to estimate it with s and then divide it by the square root of n. Let's come off to the side here and label what all of these things are. We have a random sample of 50, so that tells me that my sample size n is equal to 50. We have a mean offer associated with that sample. That's x bar is equal to $49,850. We also have a sample standard deviation based on that sample. That's S is equal to 3,300. And then finally we need our hypothesized value. So let's recall what our null hypothesis was, and that was that the mean salary is equal to $48,722. This value right here is the hypothesized value, mu naught. So let's go ahead and put all this stuff in here. $49,850 was x bar minus the hypothesized value of $48,722 divided by S is 3,300 divided by the square root of our sample size, 50. So let's go ahead and get the calculator out here. So we have 49,850 minus 48,722, that's our numerator, divided by, use my parentheses, 3,300 over the square root of 50, and that's our test statistic here, approximately 2.4170. So our test statistic T is approximately equal to 2.4170. Now anytime we have a test statistic T, I should go ahead and include the degrees of freedom. Degrees of freedom is n, the sample size minus 1. Our sample size was 50, so our degrees of freedom here is 49. Now let's go ahead and calculate the associated p-value with that test statistic. So first of all, let's just recall that we made the assumption, we assumed the null hypothesis that mu was equal to $48,722. And then we want to know, is there enough evidence to support the alternative? Is there enough evidence for the alternative? And that was that the mean salary offer for students at this university was actually larger than, let's say, the national average. Okay, so we go into this test assuming the null hypothesis. Assuming that null hypothesis of 48,722 for the mean and sample size of size 50, we get this sampling distribution of all the sample means. And that has a mean of 48,722, and it has a standard deviation of sigma over the square root of 50. But somewhere out here we happen to get our sample mean of $49,850. Okay. The p-value is actually the probability of getting a sample mean like we got, or one more extreme out here in this tail. That value, that area right there, is the p-value. Similarly, I can draw a diagram using the t-distribution, and this would be the t-distribution with 49 degrees of freedom, centered at 0. We got a test statistic out here of 2.4170. And the p-value is the probability of obtaining that test statistic or an even more extreme test statistic, assuming this null hypothesis right here. So this area out here is our p-value. Okay, so we need to find our p-value, which is equal to the probability that t is greater than, to the right here, 2.4170 2.4170. We're going to go use our table and get an approximation for that t-value. So if we go ahead and pull up our table here, here's our tail areas for t-curves. Our t-test statistic was 2.4170. This table doesn't go quite to that precision, so we're going to round to 2.4. Our degrees of freedom was 49. Doesn't have 49 degrees of freedom here, so we go to the one that's closest, 40 degrees of freedom. 40 degrees of freedom down here to 2.4, we get a tail area of 0.011. And it's important to go up here at the diagram at the top and note that it's giving us the area to the right of that t equal to 2.4, and that is exactly what we want. So the probability that t is greater than 2.4 or 2.4170 is approximately 0.011, or as a percentage 1.1%. So what this means is that assuming the null hypothesis is true, assuming that the mean salary offer for accounting graduates of this university really was equal to $48,722, the chances of getting the sample data that we did and this test statistic of 2.4170 is only about 1.1%. That's a pretty small chance of that event occurring. So do we really think that the mean is 48,722? Or do we think that maybe the mean is greater than 48,722? It seems fairly unlikely that we would get a test statistic like we did under this assumption of the null hypothesis, so we're going to reject that in favor of this alternative. So let's go ahead and state that. Two different ways we're going to state our conclusion here. First, we're going to make a conclusion with reference to the level of significance alpha. Alpha was equal to 0.05. That was the threshold that was set earlier in the problem, was given to us. Since our p-value is approximately 0.011, and that's less than alpha, 0.05, the data is statistically significant, and we reject the null hypothesis in favor of the alternative. So what we're doing is we're rejecting the null that mu is equal to 48,722 in favor of the alternative. Remember, the alternative hypothesis was that mu is greater than $48,722. The last step in this test here is to state a conclusion in the context of the problem. All we have to do is restate this alternative here in words. So mu was the mean salary offer for accounting graduates of this university is greater than $48,722. And this is because we were rejecting H naught in favor of HA. So we do have convincing evidence that the mean salary offer for accounting graduates of this university is more than $48,722, which was the 2010 average.